Ever wondered what it really takes to make a character in a game, well, move? To turn a static drawing into something that feels alive? Well, today, we're cracking open the Game Developer's Toolkit to show you how just a few lines of Python can be the spark that brings your creations to life.
I mean, if you've ever played a video game and just been mesmerized by how the characters run and jump so smoothly, you're about to see that it's not magic. It's code. And we're going to break down the absolute fundamentals that make it all tick.
So where do we even begin? Well, before a character can do anything cool like run, jump, or fly, it has to learn the most basic skill of all, just moving from point A to point B. Let's look at the one simple property that powers everything.
Say hello to dx. Now in programming, that little d usually stands for delta, which is just a fancy word for change. So dx is literally the change in x, the change in its horizontal position. Think of it like the gas pedal and the steering wheel all in one. We set this one property and it tells our shape how fast to move and in which direction. A positive number moves it right, a negative number moves it left. It's the secret ingredient for all motion.
Okay, making something move is awesome, but the real fun starts when you can actually control that movement. Now that our shape has a mind of its own, how do we step in and become the director?
All right, check this out. This is one of the most satisfying little tricks in basic animation. Here, C is just our character or our shape. By setting its dx property to the negative of whatever it currently is, we instantly flip its direction. So if it was moving right with a speed of 10, this one line makes it -10, and bam, it's moving left. So cool.
And what if you wanted to just stop? It's even simpler. You just tell it that its speed, its dx, is now 0. The animation loop will keep running, but it'll just be adding 0 to its position over and over again. And adding 0, of course, does nothing. The shape is frozen right in its tracks.
And there you have it. Those are really the two fundamental commands for controlling motion. One flips its momentum, and the other just kills it completely. With just these two lines of code, you're already well on your way to being an animator.
All right, so our shape is moving, we can control it, but it's just moving around in this empty void. Every game, every world has boundaries. Sooner or later, our little shape is going to hit the edge of the screen. Figuring out what to do then, that's one of the first big puzzles every developer has to solve. So what should happen? Should it just stop dead in its tracks? Should it pull a Pac-Man and reappear on the other side? Or should it bounce off the wall like a pinball? This is where you get to be creative, because the choice is totally yours, and it's all controlled by code.
This table lays out our three main options perfectly. Let's say our screen is 400 pixels wide. For a bounded effect, we can literally lock the shape's right edge at position 400 so it can't go any further. For a round-around, we basically teleport it. As soon as it hits the right edge, we tell it its new position is all the way back at 0 on the left side. And for bouncing, hey, wait a minute, that code should look familiar. It's the exact same trick we used before to reverse direction. We just reuse it.
It is seriously amazing how powerful that one simple line of code is. The same logic we use to make a character turn around is the exact same logic we use to make a ball bounce off a wall. Okay, let's recap. Our shape moves, we can control it. It even interacts with the walls. But does it look good? See, making things move is the science part. Making that motion look smooth and believable, now that's the art.
So if you set dx to some huge number like 100, yeah, your shape is going to fly across the screen, for sure, but it won't look smooth. It'll look like it's jumping or teleporting from one spot to the next, creating this really choppy, unnatural effect, because it's just taking these massive leaps every frame.
So then you might think, okay, easy fix. I'll just set dx to a really tiny number, like 1. And you're half right. The motion will be super silky smooth, but it's also going to be incredibly slow and sluggish. The computer can only update the position so many times a second, so tiny little steps will always mean slow movement.
So what's the secret? It's all about finding that perfect balance. First, we pick a moderate dx value. Not too big, not too small, to get a good speed. Then, we crank up the frame rate, or in this code, app.steps per second. This just tells the program to update everything more often. And the result? We get reasonably sized steps happening very, very frequently, which gives us motion that's both fast and smooth. It's the best of both worlds.
These basic building blocks, thinking about speed, control, boundaries, and smoothness, they are the foundation for literally everything in animation. So, now that you've got the basics down, where do you go from here?
Well, your next adventure could be adding gravity, so your objects can jump and fall realistically.
Or maybe you could add friction to make them slow down and stop on their own. You can start playing with motion in 2 dimensions, or even get things moving in circles. The possibilities really start to open up.
So there you have it. You now have the fundamental tools to start animating anything you can imagine. These basic principles of motion are officially in your hands. So the only real question left is, what are you going to create first?